Physics 2016 May June paper 42 question number 1. A binary star consists of two stars A and B that orbit one another as illustrated in figure 1.1. So this binary star, now what you basically understand, what you should understand is that there is a central point here P, and around that both of these stars would go. So they have their own orbits. So that is something that you must figure out. You have to read the question, look at the diagram carefully, and try to understand what they are saying. So now the details that they have given: star A has a mass of ma, and the separation between the two central points of the two stars is 2.8 into 10 to the power 8 kilometers here. And star B has a mass of mb, and the separation between the central point, that means this circle, is p, that the radius of that part is p. The radius, that is the center point, is p, the radius is d. So this is the radius of that circle. So those are the details that have been provided to us. And star A has a centripetal force towards P, and star B also has a centripetal force towards P. So they are both circling one another around that central point. Now, the stars are in circular orbits with the centers of both orbits at point P, a distance d from the center of star A. The stars are in circular orbits with the centers of both orbits at point P. So both the orbits have the central point at P. A distance d from the center of star A. So that means from the center of star A, from this star to this point is d. So that is clear. Explain why the centripetal force acting on both stars has the same magnitude. They are asking, explain why the centripetal force acting on both stars has the same magnitude. So that, in simple terms, what provides the centripetal force for something to rotate or orbit something? Right, there has to be some, if it is a piece of something that is attached to the end of a thread, it is a tension of the thread. When a star or a planet is orbiting another, it is the gravitational field strength or gravitational force. So in this particular situation, it is the gravitational force that provides the centripetal force. Now what they are asking is, explain why the centripetal force acting on both stars has the same magnitude. Why do they have the same magnitude? That is because both of these are acting, they are orbiting the same central point, and they have gravitational force on one another. According to Newton's third law, action-reaction pair, if one thing exerts a force on another, the other thing exerts the same force on the other. So that is the reason why they do not get out of orbit. They don't get thrown out of orbit, because they are, one thing is, one star is pulling it towards itself. Now for example, this star will pull it towards itself, pull this star towards that. At the same time, this star would pull it towards itself. At the same time, this star will pull the other onto the other one. So when that happens, the action reaction pair will keep them in orbit. So there is a equal but opposite pull on one another. What will happen if the other one pulls the other more than it is being pulled by the other one? So they will come crashing onto one another. It doesn't happen. So your answer should be gravitational force provides the centripetal force, and it has to be similar according to Newton's third law. Don't worry, these might sound confusing, but when you do more and more questions, you will understand how the answers are taken and how they amalgamate or combine all of the theory lessons into one particular part. Then part 2, the period of the orbit of the stars about point P is 4 years. Calculate the angular speed omega of the stars. So this should be easy for you because this is coming from a direct question. So if you have not, if you have difficulty remembering what it is about, let's go and look at the textbook. So now, angular velocity. The equation for angular velocity is this. This is the angular velocity equation. Now omega is equal to delta theta over delta t. Delta theta over delta t. So now they are asking, let's go back to the question. They are asking the period of the orbit of the stars about point P is 4 years. Calculate the angular speed of the stars. So the period has been given. So when the period has been given and they are asking for the angular velocity, we have to find the relationship between angular velocity and the period. So the period means the time it takes for one complete revolution. So that means the delta theta is 2 pi because that is one whole circle. 2 pi is one whole circle in radians. Then delta 2 pi divided by t is equal to omega. But the thing is, they have given t. What is t? T has been given as 4 years, but we can't write them in 4 years. We have to convert it into seconds. How do you convert this into seconds? 4 years into seconds. Can you remember? Let me do it here. Now the equation is omega equals 2 pi upon t omega is what we are trying to find out. T is 4 years multiplied by 365. Why? To find number of days into 24y hours into 60y minutes into 60y seconds. Right? So 2 pi over 4 into 365 into 24 into 60 into 60. Then you will get your final answer is going to be 4.98 into 10 to the power minus 8 rads per second. You will get your answer as 4.98 into 10 to the power minus 8 rads per second when you divide 2 pi by this value. I hope it made sense. If it did not, please raise questions, then we can discuss this again. Then we have an answer for that. Let's mark it down here so that if we have to use it again in the future, 4.98 into 10 to the power minus 8 rads per second. Right. Now, part B. The separation of the centers of the stars is 2.8 into 10 to the power 8 kilometers. The separation of the centers of the stars is 2.8 into 10 to the power 8 kilometers. We saw that in the diagram. The mass of star A is MA. The mass of star B is MB. The ratio MA over MB is 3. So that means one thing is 3 times the mass of the other. They are asking to determine the distance D. Now, we know something. That is, we know that their centripetal forces are equal. Then we can combine these two equations using the equation for centripetal force. I suppose you can remember the centripetal force equation. F equals, there are two equations that we figured out. F equals mr omega squared. I hope you can remember that. We can use it here. We can use it here because we know the centripetal forces of both the stars are equal. Then we can take m, let me do it on a piece of paper. MA. Now instead of R we can put D because the radius of that is D of the first star into omega squared. This is equal to MB. Then from the separation, that is 2.8 into 10 to the power minus 8, from that you can actually deduct. Now let me show you how it is done. Now this is this length. D is the radius of this circle, star A circle. Star A circle is D. But because the total length is 2.8 into 10 to the power minus 8, the separation between these two is 2.8 into 10 to the power 8, then this length, that is the distance between P and star B, this length is, from this you have to subtract D. Simple, right? Right. So then we take those values. Then MB, for distance you have to put the radius of the circle is then 2.8 into 10 to the power minus 8 10 to the power 8 rather minus D into, once again, omega squared. Right. So now they have given that MA divided by MB is equal to 3. Right? MA divided by MB is equal to 3. Now because these are all multiplications, omega squared can be cancelled out. Then you are left with MA divided by MB is equal to So I divided both sides by MB. Then from this side MB, from this side MB to MB gets cancelled out, and on this side you are left with MA over MB. MA over MB is equal to then 2.8 into 10 to the power 8 over D. Minus D into D. If that is not clear, let me do it again. I hope this is clearer. So MAD omega squared is equal to MB. Then the difference between the from the total length you subtract D into omega squared. So those two, because these are centripetal forces, they are equal. So now because it is omega squared, both sides can be cancelled out. Then I divide both sides by MB. Then on the left hand side I am left with MA upon MB. MA upon MB. Then to get rid of D, I divide both sides by D. Then left hand side, when I divide by D, D to D gets cancelled out. On the left hand side, 2.8 into 10 to the power 8 minus D is remaining. Minus D is remaining divided by D. When you simplify this, you will get D to be 7 into 10 to the power 7 kilometers. Please bear with me for the difficulty in drawing these things. This will be sorted out very soon, and the future videos will be better. I hope you understood the question, and let's move on to the next part. Use your answers in A2 and B1 to determine the mass MB of star B. Explain your working. So now in the earlier answer, you have to make sure that MA over MB ratio is 3. They have given that, so you have to use it. Okay. Then GMAMB is the relationship here. Now the second part, use your answer in A2 and B1. In A2, we got the omega to be 4.98 into 10 to the power minus 8 rads per second. So now, how are we going to make this connected with the mass of the second star, or the the B star? Right. Now the point is this. Now if you look at the question, you will understand that this is a binary star. Consists of two stars A and B that orbit one another. So that means, that is going to suggest to us that the whole system has an omega that is similar to both of them. That is similar to the entire system as well. So the entire system has the same omega, right? The same omega would be applicable to all the all parts of this binary star. So then the entire binary star would be consisting of the whole of MA and MB. Whole of MA and MB. Before we